So Todd and I can just tell you that at least from my point of view, we had a wonderful time doing this. So for those of you that are out there that are potentially going to do this talk later, it's really fun to meet with somebody that, I knew Todd well enough, but I didn't really know him. I never really worked with him before, and it was really a lot of fun putting this talk together. So
I agree. This as an exercise in learning about something that I had no background in and had not really thought about before, and figuring out what these linkages are, it was a good use of the last several weeks, and we're hoping that you'll get something out of it too.
All right, so the way that the talk's going to go is I'm going to give a little introduction to myself, then Todd's going to introduce himself, then I'm going to give some content, then Todd's going to give some content, and then at the end we're going to sort of tie them together. But you'll sort of see linkages as it goes along. All right, so I'm going to get started. For a brief history of me, my undergraduate was electrical engineering at Case Western Reserve in Ohio. I then worked for 5 years in an automotive supplier as Joe engineer, make the parts, ship the parts kind of thing. Then I decided that I was going to go back and get a PhD and become an academic. And so I went to UW-Madison, got my MS and PhD there. And my primary research topic was the design of experiments specifically related to industrial quality improvement, quality control. Then I started at Northwestern. And spent 6 years getting tenure, teaching statistics, and doing research in the design of physical experiments, which is what I had done, what I had trained for, and also had some experience in the automotive industry for physical experiments. The next 15 years was quite a change. The big change in my research was that I switched from looking at the design of physical experiments to the design of computer experiments, simulations. And how do you run experiments on simulations? Again, to collect data and analyze it and make good decisions. But instead of doing physical experiments, they were computer experiments. Did a lot of that work with Barry Nelson in the industrial engineering department. But there was another huge shift, and that was that I took over the leadership of DTC and ran that for 15 years. And I also, while running DTC, the Segal Design Institute sort of grew up around DTC. And so I became very involved in the Segal Design Institute and have continued to be. About 5 years ago, life changed again. And that's when my partner in crime, Pam Daniels, and I developed a course that Julio said, we need a course called Designing Your Life. And Pam and I created that course, founded it. We've been teaching it. We've now branched out. We've got a number of other people that are teaching it. And that has been really a huge pivotal moment in my life. And in this talk, I'm really going to talk mostly about what's happened in what I'm interested in related to the Designing Your Life course. And so that's what you're going to hear about from me. I wanted to tell you a little bit about where I came from, but for this talk, this is the stuff I'm going to mostly talk about. So designing your life, founding, leading it, and then also continuing in the leadership here in Segal. Alex Birdwell has taken over the Design Thinking and Communications, DTC, so anybody that doesn't know that news, Alex is now in charge of DTC. This is 2 years ago, just before the pandemic. I enrolled in a master's program here at Northwestern in counseling over at the Family Institute. And the purpose of that was to continue to teach Designing Your Life and to do it with some education, with some network, with some ability to know something about what it is that makes human lives better. So I'm halfway through that counseling degree now. I want to start with DTC. 15 years of DTC, 13,000 enrollments over those 15 years. And when the Wall Street Journal did an article on it, this was what they said that we taught. So now, everybody knows that in DTC what we're teaching is the design process, and what we're teaching is how to solve human problems with technology, and we're teaching students how to design. But we're tackling problems that are unsolvable, meaning there's no clear answer. And when you get done, you don't know that you got the right answer. You got an answer that's good. You don't necessarily have the right answer. And so the problem is not really solved. The problem is addressed. So what they said was, when tackling problems without clear solutions, here's what you learn: empathy, creativity, teamwork, brainstorming, risk-taking, humility, and resiliency. Those were the things that, while I'm in DTC, I'm teaching the students. And so when we go to designing your life, this is the map of those similar sorts of characteristics that we're teaching to students when they're thinking about, now I'm going to take that design process and I'm going to apply it not to designing a product or a service, but to designing the life that I'm going to live. The same sorts of principles. Here is some of the results. This is evaluations from students. You can read it yourself, but I'm okay with the ambiguity. What was once the cause of all my stress is now something I'm learning to appreciate. Here's another one. What I've missed is considering where the bigger, more important aspects of my life, like how I want my friends, family, and other relationships and passions that hold the highest value to me to fit into the picture of my life. What in the world do you teach in designing your life? Like, how does this course actually go? Okay? So I'm going to give you a really quick overview. There's the design thinking process. This is the stuff that we teach in basically every class in Segal, from freshman all the way up to a PhD, right? We're teaching things about the design process. And so these are some of the tools, not all of the tools, but some of the tools that we are addressing in designing your life. And then we also have these life concepts that are useful for building a good life. We tie those two things together into activities, which become assignments that students do, and they work together in teams to talk about their responses to those. So that's basically how designing your life works. The one that I'm going to pull out for you to talk about here is the relationships. You'll notice relationship was in the title of this talk, and that's the piece that we're talking about mostly here from my point of view, human relationships, and then we're going to make that analogy to human-machine relationships. So this is a visualization of somebody's relationship tree, which is all the relationships that they have. One of the points we make in designing your life is that your life is a lot about what relationships you have and how you tend those relationships. And here is somebody's relationship tree. Here's a little bio of that person, and here is their tree, and these are the categories of relationships that we ask them to visualize. Say, if it's a really strong relationship, like this person just got married and it's going really well, this becomes a really big branch. And then we also say, well, just because it's big doesn't mean that it's healthy. So also visualize whether it's a healthy relationship or not by making this more brown or more green. Then you just do this for all these different relationships, and we give definitions for these things, so forth. And then step back and look. Say, is that what I want? If not, what do I want to change? How do I change that? And in fact, that is the question. After the first time of presenting this, the students said, that's really great. I really like that way you looked at that. But what do I do if I want to change it? Okay, so big question. So I thought about that. It also is a very personal activity, right? So one of the other comments we had was, this class is sort of the perfect amount of uncomfortable. So we get into some pretty serious things. I'm going to come back to talk about answering that question. How do we go about changing those relationships after Todd introduces himself?
All right, thanks, Bruce. So a little bit about me. I did my undergraduate in mathematics, and then I did my PhD in control and dynamical systems, which could be fairly described as applied mathematics. And then I was here as a postdoc working with Kevin Lynch, but also was in the LIMS lab with Michael Peshkin and Ed Colgate. And it was actually here that this is the first place where I started being in any serious way exposed to the importance of human-machine systems. I had nothing to say about human-machine systems. I was grossly incompetent, and everything that I learned from the people who were here is that everything about human-machine systems is hard. And I'm going to talk a little bit about why that matters so much. But then what happened after that was I went to the Aerospace Corporation, where I was essentially a test engineer, and what I did in that context was take contractor designs and force them not to meet specifications, basically through analysis. So my job was to design very, very particular ways of eliciting dynamic responses and complicated things that are supposed to go into space, and then make everyone mad at me because their billion-dollar investment in whatever turns out to not quite meet what the government was requiring. And there's nothing like making everyone else's work fail to give you an appreciation for how hard it can be to get big teams of people working together and using different types of software that are supposed to help productivity, et cetera, et cetera. So in that context, I saw some of those things as well. And then I got out of there. Then for the last 17 years, I've been a professor, primarily at Northwestern. I've done work in methods for control, lots of work on numerical methods, but also now I work quite a bit in the area of human-machine systems, and that's what I'm going to be talking about today. I also just want to comment that over the last 9 years or so, I've been involved in lots of external significant collaborations, some of them with companies, also on Department of Defense boards. The main reason I'm bringing that up is that in that context, there's high stakes. To everyone that you work with in those contexts, they know whether they're at a company or whether they're on one of these Department of Defense boards, they know that there's a lot at stake, and so errors can't be tolerated, and also believing that you know something when you don't really know it, that can't be tolerated because there's too much at risk. And so all of this informs my interests in data and the relationship between data and human-machine systems. So robotics systems are interesting because they often operate in settings where there is no data. And I think this is sort of underappreciated. We're so used to the Googles of the world telling us about how there's so much big data that all we need to do is analyze it. But the amount of data that Google has compared to the amount of data that there could be is tiny. Because actually the richness of what happens in the world, and in particular the richness of what happens with people, is enormous compared to what's ever been recorded on a server. And so, in standard robotics, this matters because things like, how many different types of actuators could you in principle design that are soft and heterogeneous materials, and that there isn't a practical way of making physics-based predictions. There's lots of them. And oftentimes when we interact with something, we only have short time horizons for data collection. And so the question that a robot has to answer is, where does data come from, and how much data does the robot need before it can act on that data? And human-machine interactions involves people, and people have opinions about things. They're idiosyncratic. In the case that I'll talk about in a moment, where you're interested in assistants, not only are they idiosyncratic because they just like who they are and don't want to be someone else, they're idiosyncratic because they might have something like a neural event, like a stroke, that has made them different from other people, and that now we have this huge population, incredibly variable, and again, not very much data ahead of time before the interaction. And so the key point here is that people are complex, and that we need to have machines that can interact with people. And I'm particularly interested in machines that interact with people physically. I am also somewhat interested in, actually I can take this off, just realized that. So I am interested in virtual interfaces like screens, but physical interfaces are interesting because you can both assist and communicate simultaneously. And that we do this all the time. Physical therapists do this all the time. And so in a variety of contexts, we have robots that interact with people. I'm going to show you a video here. This is a young, healthy subject. And he is playing a game where the robot is helping him with this virtual game. He's trying to swing up a pendulum. And what the robot is doing is it is, at every instant in time, it is deciding whether the action that he's taking physically makes sense given the autonomy's knowledge of the task. And if it makes sense, then it lets him do it, and it remains transparent. He's supposed to, at least in principle, not feel anything when he's doing something that the autonomy gauges as being correct. And when he does something that the autonomy gauges as being wrong, it'll stop him on a dime. And this robot, by the way, this is in collaboration with Jules DeWall down at the medical school. This robot can produce 1,000 Newton meters of torque. It's more than capable of stopping someone on almost in like a millisecond. It's actually really startling when it happens. And this is an example of sort of a middle ground between two extremes of thinking about physical machines interacting with people. One extreme is that the machine is essentially a software-defined simulation of another machine. So for instance, if you think about machines that simulate admittance control or impedance control, what they're doing is they're allowing you to tune mechanically relevant parameters that you have a belief that those parameters are going to be effective at sort of supporting someone during motion, for instance. What's happening here is that the autonomy is at every moment in time, it's making decisions, real decisions, about whether it should intervene. And when it does intervene, it stops you from doing what you're doing, and when it doesn't intervene, it just tries to stay out of the way, and that decision is constantly happening. So it's sort of a software-defined, very, very low-level type of reasoning about the person's behavior based on, in this case, the physical therapist sort of defining a task ahead of time. And these types of interactions, we've also done them with people who have survived stroke. This is an example of a woman downtown game where she's trying to pick up beads. It's sort of like a Pac-Man game, and she's trying to stabilize a virtual device while she does it. And as she does so, the machine is capable of changing how much it helps her. And so it's changing the level of assistance that it provides based on performance. And I think this is a natural thing to eventually want, that like the physical therapist, the autonomy is keeping track of things like its assessment of quality of motion. I'm going to talk a little bit later about what that might mean. But the autonomy is also keeping track of whether the person actually needs assistance. And by doing so, we're avoiding things like over-assistance, which is known to undermine, if you assist at all times, imagine doing an intervention with someone, and instead of doing it once, you just do it constantly. I think we have relatives who are like that. And that's not going to be an effective way of developing the relationship between the person who's intervening and the person who is being intervened. And here we also want robots to be as minimally invasive as possible when they intervene. We want the robot to make good decisions, and it might be safety-based decisions. So for instance, I showed you an exoskeleton earlier. You might want an exoskeleton to intervene if the person's going to trip. But aside from that, try to avoid interacting with the person unnecessarily. And really, this is related to the fact that people want to be able to choose their own approaches in how they solve problems. And they might need to choose those approaches because something has happened physiologically that means that they have to have an idiosyncratic approach. But it can also mean that they just want to do things their own way. And in the previous experiment, the one where the young man was solving this cart pendulum swing-up problem, in that setting, actually, even if people recognize that the machine is helping them, it still irritates them, right? Like, they don't like it. And I think that's the other thing that I want to say here is that oftentimes in physical therapy, it doesn't matter if people like something. What matters is if they improve. And so I went through several years of physical therapy at a physical therapy place because of severe back problems. And there, they never cared if I liked what was happening. What they did care is whether I trusted them enough to let them do what needed to be done. And this all implies that there's going to be a complicated relationship between machines that help people and the people who are being helped. And that relationship doesn't necessarily rely on rather high-level and potentially vacuous notions like how much they enjoy the experience. But instead, it might rely more on how much do they experience agency while the machine is helping them. And how much does that help support their sensation of trust in the machine that it's not going to do something unexpected and that it's not going to do something that undermines their progress. Okay, so I'm going to talk about this more, but I think now Bruce is going to talk about relationship building.
So, turn my mic back on. No, it's on. So this is the model of relationship building that sort of came out of that question, yes, the relationship tree is interesting, but what do you do, right? And so the first thing that came to my mind was, well, we teach that you should do life in teams. You should have people around you. And so one thing that Darren, who is the owner of this little bio here, fictitious, just got married, is going well, lives far away from his family, and they don't get along very well with Gabrielle, his new wife. There's a number of other things here, but for the purpose of this, that's the one that he's most interested in. One thing he could do is to get together with a little team, people that he knows, and say, hey, can you give me some suggestions for how I might go about fixing this problem or making this relationship with my family better and my relationship with Gabrielle, right? So I'd like to just talk about it. In fact, that's what I'm going to have you guys do. I'm going to have you guys just get into little groups, and I'm going to give you about 2-3 minutes. The music will play. When the music is done, you're done brainstorming, and then we'll just have a few people report out what are the things you talked about. So this is your job. Brainstorm behaviors and attitudes that Darren could try with his family to address the difficult relationship with them. And here goes the music. Going? Okay. Yeah, I think it is. Oh, but I probably turned it down a little bit too much. Can you hear me now? Okay. So, some volunteers. What are some of the things you talked about? Yeah.
Have a child.
Have a child. There you go. That always makes Grandma and Grandpa happy. Yeah.
Go on a holiday together.
Go on a holiday together. Great.
Brought up the idea that find a common ground that can act as a springboard.
Good. Excellent. Yes.
Find a third party who would go with both of them and ask them about what they see.
Right. Good. Excellent. Yeah.
Family tattoo.
Family tattoo. Okay. Yeah. Great. Okay. Thank you very much. Okay. So this is something that can help, right? So, but of course, I'm not going to just stop with just that. I'm an engineer, right? I want a model that says how can we work on this problem. So my advisor's advisor's advisor is the person who came up with this quote: all models are wrong or some are useful. How many people have heard that quote before, right? How many people knew it was George Box? Oh, a couple people. Okay, so at any rate, what I'm going to create is a model, and the purpose of this slide is to let you know that this is not the truth. This is a model that's intended to be useful for thinking about relationship building, and if it doesn't work, then you don't use it. So, so hopefully it will have some use. So, taking the relationship tree and saying, okay, in addition to your relationship tree, you also have an inner life. The life that you have inside you, where you have that inner dialogue, you think to yourself, you have emotions and so forth. And the first level of the inner life that I'm talking about is called character, and it's habits of behavior. This is how you act when other people are around. I know that a lot of times people say your character is when you act when people aren't around, but it's true, that's good, but isn't it really more important how you act with other people in some sense? So, at any rate, character is your habits of behavior, what you actually do. And those are things like honesty, kindness, thoughtfulness, forgiveness, and then you'll see the grayed out ones, which is the other side of the scale, and we know that we all put those characteristics towards other people at times. And so if we all just were, honest and patient and kind and thoughtful and forgiving all the time, I bet we'd have some pretty good relationships, but that's not easy to do. So how do we go about doing that? And in particular, maybe some of the things you were talking about with Darren were maybe you should try to be kind or forgiving towards your family to try to help them come along. How you actually approach that matters. But how do you change the way that you approach things? How do you change those habits? So that's the next level, is the heart, and it seeks peace. And these are things like courage, joy, and wisdom, and those are things that actually you have to sort of have experience and time in order to create in your heart. But once you build up courage, joy, and wisdom, it's much easier to do these kinds of things well. You have more control because you have those things in your heart. The next level is the mind. This is saying, okay, well, what I want to accomplish, I'm going to try to achieve this with agency, right? I'm going to try to make things happen. And in particular, what I want to make happen is I want to make these things make my relationships good. And in order to do that, I'm going to try to build this into my heart. So how do we do that? Well, that's what we call designing your life. Here's a very simple, thank you, Kim, design model, which is frame the problem, build something, put it into the world, see how it goes. That's your relationships. Try something with your relationships. Get a reaction, learn from that. Either learn that worked well, that going on vacation thing, that could work great. But you might find out, right? So try something and see how it goes and learn from it. And that is how you get things like wisdom and courage and joy, by doing the design process, finding out how things work and so forth. But it matters what you think, right? When you frame something up, what you're trying to do is do something good. And it matters what you think is good, right? You have to have some belief that what you're doing, this is what all design is. You have to put something out in the world that you think is going to have value, that you think is good, and then you have to have some humility that sometimes it's not maybe such a great idea, and you need to reframe again. So just as a quick, so this is the entire inner life model that I present in a lot more detail. But just to give you a little example for Darren, if he believed that I shouldn't change for anyone, not even my spouse, you can see how that belief is going to have a different thing that you put into the world than the belief that I should become more like my spouse in many ways. So it matters what you actually believe is good as to the things you're going to try. Regardless of how you start, if you do the design process, you can still end up in a good place, but you might need to change some of those beliefs based on the things that you learn. Okay, but what makes this thing all work and grow? It's love. If you think about it, when you were an infant, you basically had no inner life, right? But you had some relationships. Maybe just one, maybe a couple, right? But you basically had a relationship. And that person put something into you. Probably a lot of it was love, depending on who you were and where you were, maybe more or less, but somebody changed the diapers, right? So there was some care that happened for you. And at some point, you learned that if you give some love back, things happen that are good. That relationship gets better. And then you realize that you can take that and you can give it to other people, and it gets even better. There's more things that can happen as you provide that love to others. And what I mean by love in this case is the compassion that allows you to give your heart, skills, knowledge, time, effort, reputation, and strength for the benefit of another or others. So maybe this is something that we are more likely to be able to apply to the other relationships that we're talking here than love, but it's important to realize how human relationships work, and when we're thinking about using it. So here's just a quick wrap up. 5 whys. Healthy relationships. Why? Because we have good habits of behavior, good character. Why is that? Because we have deep set feelings that drive that character. Why is that? Because we have a mindset that designs feelings in the heart to match the beliefs of things that are good. And why is that? Because we have a foundational hypothesis, values and beliefs about truth and good, which underwrite our mindset and decisions. One thing that I missed saying was on that bit about truth, the soul seeks truth, but the things that we believe, we don't know that they're true. And so that's this, but not yet. I don't know if you've heard of the growth mindset. This is a Carol Dweck point that you're trying to grow, you're trying to do better, but sometimes you don't, but you don't know, you haven't learned it yet. So it's kind of the humility attitude as well. Okay, so then finally, why does this all work? Love, it's the compassion that leads to good for all. So that is the designing your life, relationship building piece in a very quick time. And I'll turn it back over to Todd.
All right, thanks. So the connection between there are many connections between what Bruce was just talking about and what we might hope for from human-machine systems. But an important connection is that if people are used to the idea of, say, a physical therapist who's a person and has all of these attributes, all of these relationship-building attributes, then they're going to be looking for some of those attributes in the machine that plays a similar role in their progress towards regaining function or in any other setting where the machine is helping them. And so the question is, what are the engineering principles that we might expect to apply to the design of such a machine? And that's not at all clear. I mean, if we think about the ending of compassion to apply your skills and abilities to do something for someone else, the implication there is, one, that the goal is to help you, and people need to believe this in their human-machine interaction. But two, it's also the belief that it is possible. And I think that we tend to believe this instinctively about people, that when people want to help us, it implies that they will be capable of helping us. But actually, whatever it means for a machine to want to help you, I think most of us, our experience with machines is that it doesn't matter if they want to help you. They aren't going to be able to. The entire Windows operating system is an example of something that is supposed to help you and, in fact, typically can't. And so what are ways that we can design a machine's interactions, particularly physical interactions, in a way that anticipates this need? And one of the things I want to focus on is that people expect other people to be flexible. That when we interact with a physical therapist, my memory is the physical therapist yelling at me for an hour every day for 5 or 6 days a week. And even in that context, the physical therapist also knew when to back off. The physical therapist also knew when I just didn't have any more to give. And that's an important thing. That sort of underlying trust plays a really important role. And that, by the way, is something that we are terrible at in engineering. We are not good at designing systems that anticipate the need for flexibility. And that's partly because we have a long history in sort of broadly the area of precision engineering, which played an incredibly important role in the outcome of the Cold War. It played an important role in modern manufacturing. Like, it plays an important role everywhere. And yet one of my claims is that in the context of human-machine interactions, precision can be very misleading. And so I want to talk a little bit about an example in a moment. But a lot of this comes down to, like, what are the goals of machine reasoning about a person? A lot of that is related broadly to the idea of learning. And the machine's going to have to be able to assume something. I really want you to focus on these middle bullets. That the robot often knows something, and in the case, that might mean that it knows its own dynamics, say, but it knows very little and needs to incorporate the fact that it knows very little about what the person wants to do. It knows very little about what the person's motivations are and whether those motivations matter. It's also true that the learning problem is often single shot. So the technical term in machine learning is that it'll be single shot, because with a particular person, that particular person doesn't have a lot of other people that give you data that prepare you for that interaction. Instead, like, everyone is an individual. And then the only thing that robots have at their disposal, both for learning but also for interacting with people, is that they get to act, right? They don't have to learn passively. They get to do things that facilitate learning. And the way that you learn is collect data. And I just want to comment for a moment, how do we generate coverage in engineering? The standard way, the standard sort of engineering view of this looks a bit like this, that we raster scan. And yet animals don't behave this way when they're generating coverage. They do something crazy looking. And one way of understanding the difference between these two approaches to generating coverage, and therefore two approaches to collecting data, is that this on the right anticipates that maybe you need to stop earlier than you were anticipating. Like, it anticipates that things might be undetermined ahead of time. And that, for instance, if you're the fox hunting for the rabbit, you probably don't just want to scan back and forth across the prairie until eventually you happen to bump into a rabbit. You might die. The rabbit who's being wary about foxes also has to think about places that they will and will not go. And that might lead to a much more sort of organic-looking approach to foraging for food. And so I want you to think about this. We were thinking about this from the perspective that people, among other things, are data collectors, that they use their bodies to collect data. They're constantly in the habit of doing it. And I want you to ask yourself, what does this trajectory, this is a trajectory of a robot in the plane. Anyone who knows the answer, because you've already heard me talk about this, stay quiet. What is this trajectory doing? It's drawing a face. Does anyone happen to recognize whose face this is? Abraham Lincoln. So if you happen to be from the United States, you've seen this image a lot. And this is, in fact, the source image for the simulated trajectory on the right. And what's interesting about this is that drawing is a nice example of something where the goal of drawing is actually reasonably clear. If you wanted to put it in technical terms, you might want to know that at the end of the drawing, you could apply a statistical pattern recognition approach to the drawing and conclude that this was the thing being drawn. That might be one way of saying what technical success looks like. And yet the other thing that's interesting is that there are many, many ways to draw a face. And what I'd like you to do is just, for a moment, I'd like you to take the piece of paper that's next to you, and I'm not going to play any music, but I'm going to give you, once you have your piece of paper, I'm going to give you 60 seconds to draw Abraham Lincoln's face.
Yeah.
Be as complete as you can.
Got your pen.
Starting now. Okay, everyone stop. And what I want you to do is I would like you to share with your neighbor what your drawing looks like and spend a moment comparing what aspects of the drawing you succeeded at, what was the same between your approaches, what was not the same between your approaches. So just discuss for a few minutes, for 30 seconds. Okay, anyone want to share? You don't have to show me your pictures. You just have to tell me what was different. What was different between the pictures in your small groups? Yeah?
Well, I was just going to say, Todd, one thing that was interesting, we didn't draw his eyes.
Yeah.
We drew around the eyes, but the eyes aren't a distinguishing feature there because they're so sunken.
Yep, that makes sense. Anyone else? All your drawings were the same. Interesting.
Hair was a big differentiation. Facial hair on top of his head.
Yep. Oftentimes, so people who have a background in drawing often will sketch the head before they sketch the hair. And so that's actually experience driven, depending on if you've taken sketching classes and things like that and worry about anatomy before worrying about what the rest of it looks like. Other comments? Did everyone draw the same size of face? That would be very unusual. I certainly wouldn't expect it. So one of the, any other comments? Yeah, okay, so drew a face to fit the page, good. So one of the things that's interesting is that when we think about drawing, what we might want are lots of different ways of capturing the same drawing, but where the time evolution of how you converge to the drawing is allowed to be different. It's one way in which you can allow people to have a highly personalized approach to whatever it is they're doing. And the other thing I want to comment on is that drawing, even though it seems sort of like an academic exercise, there are lots of things that we do in our daily lives that are more like drawing and less like tracking a trajectory. So for instance, when I shave or when I wash myself, these are critical parts of daily life, and they have more in common with drawing than they do with sort of classical engineering trajectory tracking goals that we are used to in robotics. And so what we did is we learned how, I'm going to go ahead and skip this for right now. What we did is we learned how to get a robot to help people with drawing tasks. And what it does is it anticipates, it knows what the drawing is, but it allows people to take whatever approach they want to take as they approach the drawing. It allows them to focus on the eyes first or not focus on the eyes first. Focus on the hair first, do the entire head, then do something else. And it anticipates all of that flexibility during the assistance process. And the last thing I just want to comment on is that the thing that allowed us to assist in drawing was shifting from thinking about signals to thinking about information. that actually what's technically happening under the hood in the assistance for drawing is that it's computing information about the face and then modulating how the robot interacts with the person to maximize the amount of information about the face that the person expresses as they move. And that got us thinking about communication, that eventually humans and machines are going to have to be able to communicate in ways that are not driven by verbal communication. That every time a physical therapist or a trainer interacts with a person's body, there's communication implicit in that interaction, and we need to learn how to do that in the context of machines interacting with people, both physically but also visually. And so just recently, we've been working on how do things that are like communication naturally arise as an inevitable consequence of thermodynamics. And so this example is a recent, well, apparently that's not going to play. These are some robots that essentially just stochastically knock against each other, and that we can now predict circumstances under which those physical interactions lead to structure that has a lot in common with things like communication and emergent aspects of transferring information from one entity to another. This, of course, is extremely new to my group, but we see it as being some of the foundation of what we will eventually use to allow machines and people to collaborate with each other to establish a communication link between them. And the way that I often talk about this is, imagine that I put you in a room with someone who has none of your background. They don't share a language, they share no cultural background, yet you, with objects in the room, would be able to successfully establish some rudimentary communication with that person, even without all of that background. And this is something that I think is going to be critical to future human-machine systems. Okay, Bruce, back to you.
So the process that I talked about for relationship building really has love going up and down and other activities also going up and down between you and all of your relationships, and back and forth and back and forth. But one thing that we kind of know about love is that for love to generate more love, it needs to be given with only the hope of getting love back, not the requirement, right? We know that if we love somebody, we can't just say, well, if I do this, then you have to do that. Then I do this. That's not love. That's just a transaction. And that's what machines do, right? Machines do transactions. It's like you push the button, it does this, right? But what we need is to be more like humans who understand that you have to give things, you have to do things that don't necessarily get the exact response that you are expecting or hoping for. And so getting that sort of understanding that people have when they create relationships. So relationships emerge from this process with agency and freedom of approach for both sides, right? You know, the vacation thing, you know, well, the people are going to react the way the people react, right? And then you respond in response to that. The last thing I'm going to provide is an example. So as I said, I'm taking this Master's of Counseling degree, and one of the things that in counseling is the most important thing for the progress of the client is the relationship between the therapist and the client. And once you know that this is the therapist and this is a client, you know a lot of things about that relationship, right? But nevertheless, the relationship still has to be built. And here are the rules that we're taught for how you build that relationship. It's often called active listening, but you've seen these kinds of things before. Open questions, encouraging, telling back to the person what they've just said so that you can communicate well, reframing things, reflecting their feelings. These are the kinds of rules that we follow in the therapy relationship. And again, it's a very structured relationship, more so than many others, because the therapist is the therapist and the client is the client, and those positions stay the same, whereas other relationships, maybe there's more movement. So finally, These skills, combined with unconditional positive regard, which I think is therapist speak for love, is, however it seems, really gets results. However, it takes months or years to fully create, which is another thing that potentially the machine-human interaction is going to need in order to, we're going to need more time if we're going to take these kinds of approaches. And here are our conclusions. You want to finish that one up?
So I think you can read these, first of all. And but, you know, this idea that humans and machines need to communicate and that some of the rules of those communications are going to be technically driven in ways that I talked about, and they're going to be relationship driven in ways that Bruce talked about, that this is going to be the way that we allow machines and people to grow past their transactional relationships. And I think given the time, maybe we should first of all say, anyone who needs to leave, please feel free to do so. And also maybe open the floor for questions.
Definitely.
Can I just offer Julio said to offer his thanks in regards he had a meeting with President-elect Rebecca Blaine. So that's where he went.
Okay.
That's his regards.
David.
First thing that comes to mind for me is safety. Right? Of course, there is safety involved with human-human interaction because something can go wrong and it takes a while to recover. But we're not talking about dismembering somebody or losing a digit or something like that. So I'm wondering, I don't know, Todd, if that's more your space, if you can comment on that in terms of being able to learn but always keeping safety into account.
So it is true that safety is a major question, and that one of the problems that we have is that if you make a system safe by just reducing the amount of power that it has, then oftentimes you've also made it ineffective. And I think that one of the reasons that I think backing off a bit from our research focus on safety is that our current understanding of safety can corner you into an ineffective system. And the other part of it is that we don't really know how to measure effectiveness very well when we're talking about human-machine interactions. So there's a difference. There's a difference between a research machine that has technical engineers who work with it every day and are good at assessing its current state of safety versus a product that you would deploy and to someone's home and assert that it was safe. We're actually pretty decent at that first level of safety. We're nowhere near that second level of safety, but I think it's actually related to over-specifying the safety requirement and not having a flexible enough notion of what an effective human-machine interaction looks like. We also tend to characterize safety as unconditional, which I understand why we do it, but we don't ever do that with a person, because other aspects of the person's behavior, you know, you could come up and break my finger, but I have a deep degree of trust that you won't. And the question is, where does that come from? It doesn't come from physically hobbling you so that you're incapable of doing such a thing.
Yeah, I'm interested in what your thoughts are on the interaction between machine learning and, following the rules that are programmed to it and the human interaction of critical thinking. Is that going to ever be bridged, or is there always going to be that?
So I have a fast answer to that, and I think Bruce might have a longer answer to that. So my first answer to that is, imagine that, actually, can you page back to that big diagram of all the big table of all those, the thing that you circled, where there were like 16 different elements. Yeah, your stuff.
Okay. I was thinking about your stuff. So this one.
Okay, so I love this table of important relationships because machine learning has taken amazing steps, but I know of no machine learning algorithm that could take organic interactions between a psychologist and the person who's receiving advice and from that discern this sort of structure. And I mean, that's, and when we talk about machine learning, we typically talk about it in very broad enthusiastic terms without acknowledging that it's an extremely narrow, like the things that it's actually good at, both machine learning and AI, are extremely narrow in comparison. And so as long as we're willing to take that narrow view, I think there's a lot of room for how machine learning can bridge between people and machines. But this aspect, I don't see that happening on any time horizon that's relevant to the type of engineering that we do.
I think I'm going to take the next question instead of answer that same question. Didn't you have your hand up?
I blinked.
What's that?
I blinked.
Oh, okay, sorry. I think we're about done. I did want to just say, so I presented the relationship tree as a thing that, a thing that we use in the Designing Your Life class. But if anybody was interested in doing their relationship tree and they'd like to try it out, I have some cards up here that would help you do that. So if you want to come get a card, you can get the card, and it's got a little diagram of what to do, and it's also got a little bit.ly link that you can pull down the PowerPoint and do it if you want.
All right, thank you. Thank you all for giving us an audience.